In the previous section, we've seen how money grows in simple interest accounts and in compound interest accounts. In this section, we'll see how savings plans and investment plans work. And in this video, we'll do problems 1, 2, and 3. In the previous section, we saw how a certain amount of money, P, was put into an account, and at the end of a certain period of time, let's say in T years, this money changed to a different amount, a larger amount, because interest got added on to it. So it was a lump sum amount invested into an account, and after T years, after interest got added on to it, it became a larger amount, which was called the accumulated amount at the end of T years. But in this section, what we're going to see is a different sort of investment. What if we didn't have a big amount of money to put into our account? What if we had only small amounts of money that we can afford to put into an account periodically? And periodically would mean every month or every 3 months or every 4 months or every 6 months. So for every, let's say, month, if we were able to put $100 into an account, that earns compound interest with an APR of annual percentage rate of 12%, and if it is compounded monthly, then how do we calculate the interest? Now you can see that we don't have a lump sum. Every month, the amount on which the interest is calculated keeps changing. Every month we keep adding $100. So the calculations are a little complicated. So let's see how this goes. So we have an account. So let's put $100 into the account every month at the end of every month. So the interest that collects at the end of the first month is 0 because there was nothing in the account the entire month. We added $100 to the account at the end of the month. So at the end of the first month, the total amount we have in our account is $100. In the second month, at the end of the second month, we look at what we have at the beginning of the month. It is $100. Interest gets calculated on what was in the account starting from the beginning of the month. Since the interest is 12%, but then since interest is compounded every month, we divide by n, which is 12% divided by 12, which is equal to 1%. So 1% of $100 is $1. That gets added on to what we deposit at the end of the month again, which is $100. So we have $100. So this number in column 2 plus the number in column 3 plus the number in column 4 all added together gives us 201. So at the end of the second month, we have $201. Now let's see the amount of money at the end of the third month. So at the beginning of the month, we have $201. By the time we come to the end of the month, we calculate interest on what we have in the account at that point of time, which is $201. So 1% of $201 is 0.01 times 201, which is 2.01. So that's a typo there. So let's correct it. So we have $201. And then at the end of the month, we also have a new deposit of $100 because every month we deposit $100. So adding all the numbers in columns 2, 3, and 4, we have 303.01. So now you get the idea. Every month we calculate the interest on the prior balance, and at the end of the month, $100 gets added on. So the interest plus the prior balance plus the $100 gives us the total amount of money in the account at the end of the fourth month. And similarly, we can keep going on and on. So this is the idea of how a periodic payment into a certain account that makes a compound interest can be calculated. The calculations that we did on the first page was just for us to understand how interest is calculated in an account that has a periodic payment of $100 and an annual percentage of 12%. So you've seen that the calculations are quite complicated. Now, obviously, we're not going to do that um, from scratch every single time. So what we're going to use is a formula. So if the periodic payment, and what we mean by periodic payment is a deposit that we make periodically. So periodically would mean every month, every week, every day. It could be every 3 months, it could be every 4 months. So as long as it's at an equal interval of time, it's called a periodic payment. So R is the same thing as in problems we've done in compound interest. It's the APR. T is the time in years as usual. N is the number of times interest is compounded, or it is the same as the number of periodic payments. So the number of periodic payments in a year, let's say in a year, is the same as the number of times interest is compounded. So if we make monthly payments, so let's just say we make monthly payments, then it means that we have 12 months in a year. So that is 12 payments in a year. So 12 payments in a year, monthly payments. So N is equal to 12 in this case. So that's how we figure out N. It's by the number of periodic payments in a year. Now, this is a complicated formula. So we have A, the accumulated amount, is equal to P in this case is the periodic payment. It is not the principal. It is a periodic payment. The principal is when we have a lump sum. So P, periodic payment, times 1 plus R over N, whole to the NT minus 1 over R over N. So this is the formula that we use when we're trying to figure out A, the accumulated value after a certain number of years, or the future value of an account given all the other details. Now, suppose from this same formula, if we were supposed to figure out using the exact same formula the periodic payment given the accumulated amount. So let's say the accumulated amount was given to us, and what we needed to figure out was the periodic payment. Then all we have to do is use a little bit of algebra. So basically, we need to solve for P. So how do we solve for P? This expression looks complicated, but remember that all these complicated expressions are just different ways of writing numbers. So solving for P would mean getting P by itself. So what are the extra things that we have on the right side that we need to get rid of? So let's start off with getting rid of R over N. How do I get rid of this number R over N? So since R over N is the divisor, which means that the number is divided by R over N, the only way we can get rid of it is by multiplying by R over N. So we multiply by R over N on the right side. But since it's an equation, we multiply by R over N on the left side. So since it's an equation, we need to keep the balance. So that helps us cancel out R over N and get rid of it from the right side. However, it gets transferred to the left. Now, what else do we need to get rid of? We still haven't achieved what we want, that is, get P by itself. We still have a number attached to it. Now, what is the number attached to P now? This whole thing, no matter how complicated it looks, it's just a number. So suppose I have 5x equals 7, and 5 is the number I need to get rid of. What do I do in this case? I just divide by 5 on both sides. So that's exactly what we do. The number that I'm trying to get rid of is sitting inside this blue area. So that is, just think of it as a number. That entire thing is what I need to get rid of. So I divide both sides by exactly what sits inside that blue, if you can call it a circle. So dividing both sides by the same number cancels off the number, and what we're left with is a P. So P is A times R over N divided by 1 plus R over N whole to the NT minus 1. So what we've done is we've solved for P. So if you ever need a formula to figure out the periodic payment, this is what you would use. So if you're given the first formula, you don't need to be given the one that we just derived, because you can easily figure it out. You multiply both sides with R over N, so R over N divided on this side becomes multiplied on the other side. We divide both sides with this expression, so it's multiplied so on the right, so we divide both sides with that expression, and that's how we get the final formula that we use. So we have the first problem. If $1,200 is deposited at the end of every 3 months, so $1,200 deposited at the end of every 3 months. So this is a periodic deposit of $1,200 every 3 months. So this is the big hint that we need to see. So this is not a regular compound interest problem. This is a problem where there is a periodic payment. So therefore, you have to use the appropriate formula. So notice that the regular compound interest problem where a lump sum is invested in an account does not work in this case because we have a periodic payment. So this is the formula that works for this situation. So when you read a question, there are 3 things to consider. 1, is it a simple interest problem? If it is a simple interest problem, use the simple interest formulas. The second type is a compound interest problem where a lump sum is invested into an account. So there's just one investment, and at the end of a certain number of years, there is an accumulated amount. So that is a regular compound interest problem where you have a lump sum. So for those kind of problems, we need to use formulas related to a lump sum investment. Now, a third type of investment is where we have a periodic payment, and we don't invest a lump sum. We periodically deposit a certain fixed amount of money into the account. So here, let's see what's given to us. It's a savings account with an annual percentage rate of, that is an APR of 13%. So APR is equal to 13%. What is the value of the account at the end of 6 months? So let's write down what we have. P is the periodic payment. Remember that this is a periodic payment, not a lump sum payment, which is called the principal. So a periodic payment of $1,200. APR is 13%, so that's 0.13. N is the number of investments, or rather number of deposits or payments in a year. So if you're going to make a deposit every 3 months, the total number of deposits in a year is 4. So therefore, N is equal to 4. the number of years that we leave this amount or these amounts um, in the account is 6 years. Now we have all the details that we need to figure out the value of the account at the end of 6 years, which means we need to figure out A. So we use the formula, plug in all the numbers, and I've said before that when you make these calculations, you need to enter all the numbers into the calculator using parentheses all at once and hit the enter button once to get your final answer. So that way, you're not doing bits and pieces of the calculations, which will take you away from the um, the precise answer. So you need to enter everything together into the calculator and hit the enter button once. So at the end of 6 years, with a periodic payment of $1,200 every 3 months, we get $42,630.43 dollars. So, so the first part of the question was to find the accumulated amount um, given all the information. Now, the second part of the question is about figuring out the amount of money that was earned in the form of interest in this particular investment, which is also called an annuity. So the amount of interest is the total accumulated amount minus the amount that you put as payments. So P is for all the payments. It's the sum of all the payments, not just one payment. So we know the accumulated amount. All we need to do is figure out the total amount in payments. So this is how we do it. So every 3 months we deposit $1,200. So the total amount of money we put into the account is $1,200 every 3 months. Now, in a year, there are 4 payments because every 3 months in a year would amount to 4 payments in 12 months. So $1,200 times 4 is the total amount that we would put into the account in 1 year. But the process continues for 6 years in this problem. So the total amount of money that we put in is 4,800 per year times 6 because we've uh, put payments for 6 years, and that is a total of 28,800. So now we're ready to calculate the total amount of interest. So interest is the accumulated amount, which we calculated in the previous part of the problem, that is this answer, minus the amount of money that we put into the account in the form of payments for 6 years. So the difference between these two would give us the amount that we earned in interest, which is $13,830.43. This is another problem. Um, let's see, the periodic deposit. So we know it's not a regular lump sum payment, it's a periodic deposit. So we have to think in terms of the formulas that we need to use. So this is the formula that we're going to use. So the rate, interest rate, it's compounded monthly. So that means we're going to pay 12 times into this account. We're going to invest by putting in 12 payments of the exact same size into this account. So N is equal to 12. It's the same as the number of times interest is compounded, and it's the number of payments in that particular year. The APR is given to us, 0.0825 if we convert it to a decimal. The total amount, which is our goal, is given to us, and we need to reach this goal in 40 years. Remember that this is in years. So what is the periodic payment? In this case, we need to figure out the periodic payment given the accumulated amount. So we use the formula for P. So P is equal to our goal, which is the accumulated amount, the interest rate, APR, divided by the number of payments in the year, which is 12. And in the denominator, we plug in all the numbers, R, N, and T. As I said before, and I say this over and over again, enter all the numbers into your calculator using parentheses. Hit the enter button just once. Do not do the calculations in bits and pieces. So that would give us a total of $399.58. So in order to accumulate an amount of 1,500,040 years at the given rate, our periodic payment would have to be $399.58. So this would be a monthly deposit because it's a payment every month. So that is our periodic payment. So given the accumulated amount, we figured out from using the formula what the periodic payment is. So a monthly payment of 399.58 is required to make that an accumulated amount of $1.5 million. Just like the previous problem, now the second part of the problem is to figure out um, what is the interest amount that is earned in this case. So we know what the accumulated amount is. We again need to figure out what the total amount that we put into the account in the form of monthly payments. So let's look at this calculation. So the total amount that we invested in payments is $399 in 1 month, $399.58 times 12 in a year, but we've kept this going for 40 years. So this gives us the total amount that we put in the form of payments into this account. So that is our investment. So the accumulated amount minus our investments would give us the amount that we earned in interest, and that is the amount that we earned in interest. Another one of the same type of problems. These type of problems are important, so I have done 4 of these problems where we either have to find the accumulated amount or the periodic payment. So at the age of 25, to save for retirement, you decide to deposit $75 at the end of each month. So the minute we see this, a monthly deposit of $75, so it's a periodic deposit. So we know we need to use a certain set of formulas to figure out either A or P. So this is the formula that we need to use because the question says how much will be in the IRA, a retirement account, when the person is 65 years. So what is the total amount of time that we've invested in this account? 65 years minus when you start, which is 25 years, so that would be 40 years. So that's how we calculate the amount of time that we've invested in this account. So the time is 40 years. The rate is given to us. It's 6.5%, so that changes to a decimal, which is 0.065. The number of payments, since it's a monthly payment, the number of payments that we make in a year is 12, and the periodic payment amount is $75. We have all the information we need to figure out A. So we plug in all the numbers and enter all that into the calculator. Just make sure you're entering all the numbers with parentheses. Just copy this into your calculator, hit the enter button, and get your final answer, which is the accumulated amount. So if we deposit $75 monthly at an interest rate, annual percentage rate of 6.5%, then the total accumulated amount is $171,271 and 42 cents. So that is the accumulated amount. The next question that follows is just like the ones we've seen before. How much money is earned in interest? So we have a total of this amount, $171,271.42. But part of this has come as in the form of interest earnings. So again, it's the same idea. Interest earned is accumulated amount minus the total amount that we put in the form of payments. So the total payments is $75 per month. So in a month, it's $75. In a year, it's 75 times 12. And in 40 years, it is 75 times 12 times 40, which is $36,000 in 40 years. So now we are ready to figure out the amount of interest earned. So A is the amount accumulated at the end of 40 years minus the amount that we invested into the account in the form of monthly payments for 40 years. And the difference is the interest earned in this account. So if we want to figure out the fraction of the accumulated amount that has been earned in the form of interest, then all we need to do is take $135,000, 271.42 divided by the total amount accumulated, which is $171,271 dollars and 42 cents. And this gives us the fraction. And if we multiply it by 100%, then that gives us the total percent of the accumulated amount that has been earned in the form of interest.